Hello families, welcome to the equivalent fractions tutorial for homework this week. So homework this week is going to be just a little different. It's going to be two small sheets. They're actually going to be side to side on a piece of paper. It's only these two. The back is going to be left blank as a spot for kids to show their work. So we definitely want them to be in the habit of showing their work. And so this week we are talking all about equivalent fractions, and they should know that the word equivalent sounds a lot like equal. And so equivalent fractions are fractions that are equal or that have an equal value. So as a mom, I always say these are fractions that my kids are not going to fight over. They are all equal. And so one way that we do equivalent fractions in fourth grade is we use models. And so model is just like a diagram or a picture like you can see right here. And so this first, we call this a tape diagram. It just looks like a piece of tape kind of pulled out. And it's easy to use because we can just really kind of line them up. It's definitely easier than trying to use circles with showing fractions. So I do encourage students to use a tape diagram if they have that choice. And so this first model, I do have it split into two sections. So our denominator is going to be 2. I'm going to shade in one section. So that's going to give me a fraction of 1/2. Now, if I'm looking at an equivalent fraction for this next model, it's already cut into 2, but I'm going to go ahead and split each section again. So now I have 1, 2, 3, 4 parts, and I'm going to shade in the same amount. So they are showing an equal amount shaded in. But because I had split it up, instead of one part, there's actually 2 sections shaded in. So that is 2/4. And then this last one, if I were to split it in half, that would give me 4ths. But then if I split it in half again, that would give me 8ths. And then if I shade in the same area right here, it gives me 1, 2, 3, 4. So then that gives me 4/8. So that is one way you'll see on your homework. They do on the homework use a lot of circles though, so you do have to be a little more careful with that. If you would like to take that circle and turn it into the tape diagram, you are more than welcome to do that as well. They both are the same thing. They are equivalent. Another way that you can look at equivalent fractions, and we're actually going to talk about this tomorrow in class, is you could just straight up use multiplication or even division to determine equivalent fractions. And this is something they're all pretty familiar with already. So if I have 1/2 and I multiply both the numerator and the denominator by the same number, it's going to give me an equivalent fraction. So 1 times 2 is 2, and 2 times 2 is 4. So 1/2 and 2/4 are equivalent. And you can do it with really any number as long as both the numerator and the denominator are exactly the same. So 1 times 10 is 10, 2 times 10 is 20. So 1/2 is equivalent to 10/20, which is also equivalent to 2/4. And then at the bottom, maybe just did 5. 1 times 5 is 5. 2 times 5 is 10. So that gives me 5/10. So all of these fractions right here are all equivalent to each other. So if you ask one kiddo, do you want half of this pizza pie or do you want 10/20 of the pizza pie? Doesn't really matter. It's the same amount of pizza happening there. And with division, it's kind of the same thing, but you're just going backwards. So if I had 5/10 and I wanted to find a fraction that's equivalent, I could divide both of these by, again, the same number. So with division, you do have to make sure it's something that's divided equally. Because we just did it right here, I know I can divide them both by 5. And 5 divided by 5 would give me 1. And 10 divided by 5 would give me 2. So you can go both ways with that. In addition to equivalent fractions this week, we're going to look at fractions that have a missing value. So here you can see you have 1/7 equals blank 28. And here's where that multiplication is going to come in handy, because we're going to have to know 7 times something gives us 28. And then whatever we multiply at the bottom, we do also have to, multiply at the top. And so I know, because I'm fluent with my math facts, that 7 times 4 is going to give me 28. So if I do times 4 at the bottom, I also have to do it at the top, and that's 1 times 4 is 4. So 1/7 would be equivalent to 4/28. And it can totally go the other way around as well. If you had 1/7 equals, you could have 4 right here or 28 right here. You could be missing any one of these numbers, and you could still use that multiplication or even division to help you figure out that missing number in the fraction, either the numerator or the denominator. And one last thing that we're going to hit on this week is simplest form. You might remember that from school when your teachers always told you, show your work, simplest form, simplest form. And so we're going to go way back to the beginning of the year when we talked about factors. And factors are just two numbers that you multiply together to get an answer. So for an example, factors of 6, we did factor rainbows. We start with 1 and 6 because 1 times 6 is 6. 2, and then 2 times 3 is 6. And our next number is 3, but we already have 3 there. So these are it. We're done. So our factors of 6 are 1, 2, 3, and 6. So we're going to look at the factors that we have for these numbers to help determine that simplest form. So students should clear out those cobwebs and see that 3 and know that 3 is a prime number because only 1 times 3 will give you 3. So I'm prime, P-R-I-M-E. The only factors are 1 and me. So there's that prime number 3. But the factors of 4, students should already know, that's an even number. It is not going to be prime. So our factors of 4 are 1 times 4, and then 2, times 2. And so we just kind of put a box around that so that we know it's 2 times 2. So the factors of 4 are 1 and 2. And when we look, we really don't have anything in common other than 1. This one doesn't have a 2 or a 4. Down here it doesn't have a 3. So 3/4 is already in simplest form. You cannot reduce it anymore. But if we look down here at 4/8, again the factors of 4 are 1, 2, and 4. And our factors of 8, 1 times 8, 2 times 4, 3, you can't multiply anything by 3 to get 8, and then that gets it right up to 4. And so if I'm looking here, we have 2 and 4 in common. So that way I know that I can actually divide both of these numbers by 4 in order to get my simplest form. So 4 divided by 4 is going to be 1. I'm running out of room here. And then 8 divided by 4 is going to be 2. So 4/8 in simplest form is 1/2. So again, it's finding an equivalent fraction, but it's in that simplest form, as small as you can make the pieces. I shouldn't say it's small, as few number of pieces that you have, because the 1/2 piece is actually going to be a lot bigger than a 1/8 piece in size. So that's the simplest form there, and we'll hit this more in class, but they will see it on homework. They may or may not be ready for it since we haven't done it yet. And this week, here's a couple of examples of work that we're going to do this week, and I really, the students must show their work either with models or multiplication, whatever they feel most comfortable with. So a question might be, is it equivalent to 2/5? So I would actually either draw my tape diagram, got to do our best, 1, 2, 3, 4, 5, so that's 2/5. 1, 2, and then let's see, we've got 4, 6 right here. 1, 2, 3, 4. Well, you can already tell right there that it's not. Or I could do 2/5, 4, 6, and I know 2 times 2 is equal to 4, but then 5 times 2 is not equal to 6, so it is not going to be A. So students need to show their work either with models or with that multiplication. Either way is fine, but again, they need to show that work. I should not just see a circle up here. And then they'll also have just some shapes like this that will show you the fraction, and a lot of times students just want to look and count, and nope, you have to actually determine what this fraction is. So here I've got 1, 2, 3, 4, 5, 6. So I know my denominator is 6, my numerator is 1, and again I can either show with multiplication or with my models. Let's see, I know 1 times 2 is 2, And then I did 2, so I have to do 2 right here. So 6 times 2, nope, is not 3. So these are not equivalent to each other. And again, if I prefer to do models, I can just make sure both of your tape diagrams are equal length. So this first one is 1/6, and then this next one is 2/3. So there's 1/6, and there's 2/3, and you can definitely tell that they are not equivalent or the same. And as we continue on with our fractions unit, we will kind of move away from the models and look more just with multiplication, but this is definitely still okay to use if your child would prefer to use models. As always, please just let me know if you have a question or a concern about homework this week, and I am more than happy to help. Thanks.